Today we're going to be talking about the distributive property. And this, again, is another property that we're going to be using a lot in our mathematics classes. So what the distributive property is if you have a number outside a parenthesis, and then you have the sum of two numbers inside the parenthesis, we take and we multiply that a to everything inside the parenthesis. And then you multiply the a inside the parenthesis, whether it's addition or subtraction, making sure if we're addition, we keep the sign. Making sure if we are subtraction, we keep the sign. So use the distributive property to rewrite the expression and evaluate. So some of you may not understand the point of this. The point is you can sometimes use your distributive property to make problems a little bit easier. So what I could do is I could multiply this 3 to the 12 and 3 to the 17. So I have 3 times 12 plus 3 times 17. Now that might be a little bit easier for me to multiply because I can do 3 times 12, which is 36, without much problem. And I can do 3 times 17, which is 51. And then I would just add those two together to get 87. Rewrite each expression, or the expression technically, using the distributive property. Then simplify. So again, you're just taking the 12 and you're multiplying it to the y. You're taking the 12 and you're multiplying it to the 3. So I have 12y. So what I have here is I have 12 times y plus 12 times 3. Well, 12 times y, we just write that as 12y. 12 times 3, there's no equal sign. It's a plus sign in the middle, is 36. Okay, so multiplying this 4 through to everything inside. So I have 4 times y squared plus 4 times 8 times y plus 4 times 2. So what I do here is I have 4y squared, that's 4y squared. 4 times 8, I can multiply just those. It's not like I distribute the y or distribute the 4 to also the y because it's 8 times y. So everything's just being multiplied together. And then 4 times 2 is 8. Like terms. There are terms that contain, like terms are terms that contain the same variables with corresponding variables to the same power. So 5x squared is not the same as 2x because my power here and my power here are something different. Versus here 6a squared and a squared are the same thing. So I can combine those terms, technically simplifying that would get me 7a squared. The 2a is not to the power 2, so I can't combine it with the 7a squared. So simplifying this, again, just add the 17 and the 21 together. So I have 17 plus 21 is a 38a. That's all you have to do in that case. Simplify this. So again, make sure that you're combining your terms that have the same power. B squared and a b, those are the same power. So I have 12. I subtract the coefficients. So that's 4b squared plus 6b. The 6 cannot be combined with the 4. The 6b cannot be combined with the 4b squared because this power, oh, that didn't mean to do that. I meant to highlight. Because this power here is not the same as the power on b, which technically the power on b is a 1. We just don't write it because we use it so often. Okay, example 6. use the expression 6 times the sum of x and y increased by 4 times the difference of 5 and y. Ooh, there's a lot going on there. So I need to write an algebraic expression for this. So 6 times, so that's 6 times something. The sum, so that's an addition, x and y. Increased by 4 times, ooh, I was gonna go too much there. Increased. So that means, increased means I add. Increased by 4 times, the difference of 5x and y. The difference of 5x and y. And when you see the difference of those things, the first one that they list here, the 5x, is the one that comes first. So I then distribute. I distribute the 4 to the 5. So I have 4 times 5x minus 4 times y. So I'm simplifying here. So I have 6x plus 6y plus 4 times 5 is a 20x minus a 4y. So I have 6x, 20x. Those are like terms, though those are the same variable, so I combine them under addition. 6y minus 4y, 6 minus 4 is 2, so that is a plus 2y.